Okay, we are going to do 2.8 and 3.6, which are higher order derivatives and the product rule. So first we're going to go over the notation for the higher order derivatives. So there's a couple of different ways it can be written, and they're all interchangeable. So if you look at the first derivative, we can use y prime, f prime of x, dy over dx, put the d's on the outside of your function, and if you're doing an application, it's going to be meters per second for the first derivative, okay? Second derivative gets 2 slash marks, and we call this y double prime, f double prime. Notice the d2 and then the x2. So this is the derivative of the y function twice with respect to the x variable. That's why it's written like that. Same thing here, and if you're doing an application, it's really meters per second, and if you write that out on every response, you would get full credit. If you want to abbreviate, it's meters per second squared. Third derivative, fourth derivative, fifth, and so on. Okay, so notice at 4, we just put the number up there, so it doesn't mean an exponent. All right, so let's do number 1. So we really want you to practice your notation. Okay, clearly label things, you'll get better, and you'll also be able to understand what you're reading mathematically. So for the original function, we've got x cubed. So our first derivative is going to be the power rule, 3x squared. To find the second derivative, you just keep going. So do another power rule, and we're looking for the third derivative. So I'm going to keep going one more time. That's like x to the first, so bring that down. I get 6x minus 1 would go away to 0, which x to the 0 is 1, so I just get 6. All right, and if you can go from there to here without this step, that's fine. You don't have to show me that work. All right, let's try another one. So I just want a different color. Let's do red. So we want the fourth derivative. So I'm going to write this as, if you want to change the notation, you're welcome to. Otherwise, let's look up here, and we just put the 2's. So notice they're going to actually start with the first derivative, okay? So our second derivative, and this will take you a while to get used to. I don't use this one as often. Power rule. So 20x cubed minus 3. Our next derivative is a power rule, so 60x squared. Our 3 goes to nothing. And so our fourth derivative, I'm going to put it up here, is the power rule, 120x to the first. All right, so our next example is trig. So same thing, we want the fourth derivative, but notice this is our original. So the derivative of sine is cosine. Our next derivative, I'm going to get some more space. The derivative of cosine is negative sine. Our third derivative, well, the negative 1 can stay. The derivative of sine is cosine. When you multiply, remember, it just stays multiplied. And our fourth derivative, if you want, you can put the 4 marks there, but I'm just going to put the little 4 there. The negative 1 stays, and the derivative of cosine is negative sine. We do want to do some cleanup, so 2 negatives make a positive. All right. So acceleration is when you do applications, and it's not quite as complicated as physics, okay? So acceleration is the derivative of velocity, and it's the second derivative of position. So the way it works out is if, and usually this is like x of t or s of t on an application. They don't usually use y. But if it's the original function, we let that be known as the position. The derivatives so I'm going to let that be derivative. That is known as velocity. So it's the change in position. And our second derivative of the original, well, it's the change in velocity, which is acceleration. Okay? So right here, the position of a particle is given by this equation. So what I'd like to recognize is that this is the original, and I always write that on my problems just to help. So they give you the function, find the acceleration of the particle when t equals 3. So if I want acceleration, that means I want the second derivative. Okay, so our first derivative, I'm just going to line them up. This is a power rule. All right, and then our second derivative. So whatever it takes, another power rule. Minus 6t, the derivative is 6, the derivative of 5 goes to nothing. So now that's my general, that is my general derivative, but I want at a specified time for the acceleration. So x for the notation, we just plug in 3, so 24 times 3 minus 6. So what do we get? 12, 1, 72, 72 minus 6 is 66. Since this is acceleration, it's meters per second squared. All right, or meters per second if you want to write it out. You're welcome to. All right, our next example is kind of tricky if you've never seen it. So the velocity of a particle is given below. So notice this is my first derivative. I like to just make note, okay? But they also say that's velocity. Determine the acceleration of the particle. So remember, acceleration is the derivative of velocity, which derivative is slope, and they gave us velocity. So I need to find the slope that goes through 5. And you notice they don't have 5 on here, but that's okay. There's a couple of correct answers, but the best answer, okay, when they give you a table is they want you to find the best or closest interval that includes 5. So if we go from 4 to 6, that's going to include 5. And so this is going to be an approximation, and they know that. So if I want to approximate the derivative, I need to find the slope value. So y minus y over x minus x, and it's through those 2 points. Remember, time is like your x, and the velocity are your y values. Just go in the same direction. So we get 16 minus 10 all over 6 minus 4, which is 6 over 2, which is 3. And now, since this is meters per second, it's meters per second or meters per second squared. All right? The product rule. Now, this rule may seem irrelevant for some of these problems, but once we learn more derivative special functions, this is going to become mandatory. So we're going to practice it right now. So the way it works is when you have any two functions that are being multiplied together and you don't want to simplify them or you can't. So this is really hard to memorize. Even I don't memorize it like that, but I let the first function be 1 and I let the second function be 2. And so the way it works, and they kind of wrote it backwards, is, well, this is 2, the derivative, this is 1, f is 1, g prime is 2. And so 2 prime 1 plus 1, 2 prime, nobody remembers that. But if I take this part first, I can call it 1 d2, which says take 1 and multiply by the derivative of 2, 1 d2, plus this is now 1 d2 plus 2 d1. And I even wrote that one backwards. See how I don't do it this way? So 1 d2 plus 2 d1. And that kind of rolls off your tongue better. All right? I don't even memorize all these words. So let's look at example 1. Now, for some of these functions, especially like number 1 and number 3, you have some options. So I'm going to do this one 2 different ways. And honestly, I'll let you pick on your homework which way you want to do. We'll get to problems like 2 where you have to use it anyway. So I'm going to let x squared be 1, and then 2x minus 2, that's going to be 2. So if I do 1 d2 plus 2 d1. Well, 1 is x squared. The derivative of 2, so 2x minus 2, that derivative is 2, and then that goes to 0. Plus, rewrite 2, and then the derivative of 1 is a power rule, so 2x. So then we need to clean this up. So 2x squared, we're going to distribute 2x, so 4x squared minus 4x, and combine like terms. Oops. It's hard to erase. Okay. Oops. So I'm going to make this 6. 6x squared minus 4x. And that's your derivative. It's fine. Let's say I want to do this a different way. You really can distribute first. So we get 2x cubed minus 2x squared, and that's the original. So when I go to take the derivative, we've got a power rule. So 6x squared minus 4x. And notice our answers did match up. One is much quicker than the other. Okay, but that's the process of the product rule. So now let's do an example where the product rule is mandatory. All right, so we're going to let 3x cubed be 1 and sine be 2. So our derivative is 1 and then d2, so the derivative of sine is cosine, plus, and I know I'm going to get in that space, 1 d2 plus 2, and the derivative of 3x cubed is going to be 9x squared. Now, these are separate. I can't multiply that x by that 9x squared. So when we go to rewrite our final answer, we usually want to put the function in front and the trig function second, so it's clear. Okay. Now, on the product rule, one of the most common strategies is common factor. So if this was multiple choice, that's how the answers will typically be written. Okay. So if I take my common factor, they both can take out a 3x squared. So I get cosine x plus 3 sine x. Okay. Now, something like number 3 is optional. If you want to do the product rule, you're welcome to. If you don't want to do it on your homework, you don't have to. I'm going to kind of see, you know what, I don't really want to, or maybe I don't remember it, and I don't have to use it yet, and I recognize that too, so that has value. So we are going to have to simplify this though. So we're going to multiply 2x cubed minus 3x to the 4th minus 8, I know I'm running out of room, and plus 12x. So when we go to take our derivative, they're all power rules. So f prime of x, I'm going to do them in order. That's a 4. Now, actually, I don't even need to do them in order. So 6x squared minus 12x cubed. 8 goes to nothing, and then plus 12. I'd be able to recognize that, and your answer's not incorrect if it's not in numerical order of exponents. Okay? All right. So if we want to generalize this, we've got 3 we're not going to do in this class. All right. So basically it says you take your original times each derivative. So it's really, really long. The AP Calc test will not do a product of 3 functions. All right, let's look at our example. So the position of a particle is given by this function. So if that's position, that means that this is our original. Okay, I like to make a note. And find the acceleration. So I want the second derivative, and they're going to give us a value. So my first, which is velocity, and if you want to change x, v is recognized as velocity, so it's your choice. But this is going to be 1, and cosine is going to be 2. So our derivative is 1 The derivative of cosine is negative sine. 1d2 plus 2, and then d1, I'm going to put in parentheses, it's a power rule, 2t minus 4. All right, so, well, if we want to find our next derivative, there's not much to simplify. So I'm going to go ahead and start with my acceleration. So acceleration is recognized as the a function. And it's going to be two product rules. This is 1, this is 2. Then I'll have to do it again. 1 and 2. So this is a pretty tough question. So our acceleration is 1. The derivative of negative sine, so we get negative 1, and the derivative of sine is cosine. 1d2 plus 2. d1 is going to be a power rule, so 2t minus 4. All right. Now we're going to do the product rule again for these two. So 1 d2 plus 2, and the derivative of cosine is negative sine. All right, so what we need, we've got 1, 2, 3, 4 terms, and we need to see if we can clean this up a little bit. So what I notice is they're all different. These kind of look the same, but those are both negatives. So we are going to go ahead and plug in t equals pi over 2. Everywhere we see a t. Oops. All right. Okay. And so what we need to remember is if we have sine, so sine looks like this. So at pi over 2, and then here at pi, we get 1, and then that's at 0. So if I'm plugging in cosine, so this is sine, and this is cosine. Pi over 2 is 0. So the cosine of pi over 2, this is 0, and since all of that's being multiplied, that wipes all of that out. So let's find another one. Here's cosine. Cosine of pi over 2. Well, that's 0, so that wipes out that term. I can't wipe out these two. But if those are the same, I've got, it's really minus 2 sine, and then 2t minus 4. So if we plug in pi over 2, well, the sine of pi over 2 is 1. And then that's pi over 2. So we get negative 2. And then 2 times pi over 2, the 2 is reduced, so we just get pi. And then minus 4. Which gives us negative 2 pi plus 8. And that's our acceleration. We don't have a label here like meters per second, so you don't need to label this answer. Ooh, that was kind of exhausting. All right, this is our first special derivative outside of trig. So E, just as a reminder, E is a special number. It's 2.7182828459045. E is like exponential growth, okay? What's nice about E is it's a special function, and because of the rate of change, the way it works is that all the slope values are actually the same as the original values, y values. So E is its own derivative. That's pretty pretty special. And it makes calculus a little bit easier. All right, so now we're going to get to some mandatory product rules. So we're going to make 3x squared 1, and e to the x is our second term. So we can do 1d2 plus 2d1. And so this is how the AP is going to test you on the product rule. They're going to make it mandatory. It's not going to be on an optional derivative question. So 1, y prime, 1, the derivative e to the x is e to the x, plus 2, and our power rule. Now, because they both have e's and they both have x's, this is why we use common factoring. So we can take an e to the x out. We can also divide by a 3, and we could take out 1 power of x. So remember, this is one term, and this is all one term, and you want to see what they have in common. So if I take an 3x e to the x out, take a 3, divide it, x e to the x out, that's all that's left. So this is the best answer. Okay, well, you give your practice a try and let me know how you do.